That's it.
Are we okay now?
Yeah,
can
okay
you,
now.
Yeah.
Okay, so we are seeing my presentation now.
Yeah, can you move the slides so we make sure?
Yeah.
Yeah. Okay, you're moving now.
Okay, good.
Please continue. Yeah.
Okay, so so I'm saying that today's presentation, I will go a little bit on passive fire protection, go into the fire code. I have parts where I pick up some NFPA similarities with the Singapore fire code. And if we have time, we do some showcase, yeah? So just now I was saying that it is best to prevent the fire. But if we cannot prevent the fire, the best thing we can do next is to contain the fire. And to contain the fire, there are various ways. I think today's, our colleagues today, all the videos I noticed, we are very knowledgeable and have a lot of very good development in active fire protection. That means signaling, suppressing the fire, controlling the fire. These are measures which we call active measures. But for passive measure, we are doing something that is not visible, like making sure that the structure is protected during a fire, making sure that the building envelope, that means the external of the building, do not spread fire from one place to another, one building to another. And within the building, we divide the building into smaller compartments so that it's easier to control the size of the fire. And also, important is we want to ensure that one part on fire, the other parts of the building can still operate. So this we would call passive fire protection. But in many ways, passive fire protection is proactive. That means we design the fire protection into the building at the design stage. But this part is theory, but I think it's very important for us to understand. When we talk about fire resistance, fire reaction, what do we actually mean? Let us be very clear today. I want us to remember two important words. One is reaction to fire, where an item, a material that you're looking at, when you introduce heat, how does it react to the fire? Does it start burning? Does it give up smoke? Does it cause the surface to burn very quickly? This is reaction to fire, talking about a particular material's way, behavior, and reaction when a heat source is introduced. Okay, very good. We are all very familiar with the word non-combustible. So a material can be reacting to fire and doesn't combust, is non-combustible. But what we are important for us to build an element of construction in the building, we need to concern ourselves with the resistance to fire. Resistance to fire is not just the material alone. Resistance to fire is the entire construction, the entire wall, the entire column, the entire beam, resisting fire, an entire partition, a wall, preventing fire from spreading from one side to the other side. Okay, so to measure resistance to fire, we actually have three criteria. For a load-bearing element, it makes sure that it doesn't collapse, when it's burned. Integrity is it doesn't allow the passage of flame from one side of the wall or one side of the ceiling to the other side. And the last criteria is called insulation, is the prevention of thermal transfer. So these are the three criteria to measure fire resistance to fire. So just to recall, load-bearing capacity, integrity, and insulation. There are other aspects about resistance to fire that are good to know, like impact resistance, whole stream, and radiant heat. Okay, so remember these two words, reaction to fire and resistance to fire. Now, reaction to fire, everybody can say, this is non-combustible or this one doesn't spread fire, but there should be a consistent way, a standard of which you can determine whether your material, how your material react to fire. So here I'm presenting the European standards and the British standards. Okay, how do I compare this with American standard? American standard has different ways to, very similar way to describe the reaction to fire. But I think one of the common description that is the highest performance is non-combustibility. So you have EN standard, British standard, and ASTM standard. The highest performance is that material react to fire by being unable to combust. So it's non-combustible. Again, this is only confined to the material alone. It doesn't tell you whether this material can stand there, become a wall, and stand there for the duration of the fire. So now we're talking about resistance to fire. Resistance to fire also has a standard of testing. We are talking about full-scale destructive tests subject to a curve, a fire temperature curve to represent what is being burned in the building. You see here various graph. The vertical axis measures the temperature. The horizontal axis measure the time. For our building reference, we are looking at the red color curve called the standard cellulosic time temperature curve. Why is cellulosic? Because in our building, we are using a lot of cellulose, paper, wood, our fabric. All these are very cellulosic material. So it means in this furnace, it will be fired following the red curve. In front of the furnace will be the wall that you want to test. If it is a wall, you test it vertical. If it is a ceiling, you test it horizontal. So it's a full-scale fire test. The other curves are good to know, like in Rayong, you have a lot of petrochemical establishments, and those kind of fire will be very different from the red curve. You'll be using the hydrocarbon curve. The other interesting curves relates to tunnel, because a tunnel with roads and with heavy goods vehicle will have different fire load, and that's why the kind of fire you expect in a tunnel will be different from a building. So these are testing resistance to fire. Now, what do you measure when you want to test resistance to fire? Okay, we measure, just now I mentioned, the load bearing capacity. So something that supposed to take on load must be able to resist the fire while the element is being loaded. The second criteria is called integrity. You cannot have a crack, you cannot have a passage of flame from one side to the other side. And lastly, is this term called insulation. Okay, now I just review to you load bearing capacity, or the word stability, integrity, and insulation. Insulation actually makes sure that on the other side where you are standing to observe the performance, the maximum temperature cannot exceed 180 degrees. And the average temperature cannot exceed 140 degrees from ambient. And the European and British way of stating this performance is called REI. R is load bearing capacity, E is integrity, I is insulation. And I here also draw upon the ASTM way of testing, where they call it load carrying ability, transmission of hot gases, and transmission of heat. The American standard has very unique system testing regime for fire stopping and for building joints, where they measure also the integrity and insulation, but they call it FT. And they have another test called whole stream test that will give you the FTH. So just a good comparison between the European and British and the American way of measuring resistance to fire. So now, just as a summary, you look at a load-bearing element. What is an REI? If it is a structure only, you only look at the R, which is, say, it's 120 minutes, R 120. If it's a load-bearing floor, because the floor is a compartment floor, you will need to fulfill REI 120, 120, 120. If your element is non-load-bearing, then you will be looking at REI 120. Or it could be EI 120 0. It means it has it fulfills integrity, no passage of flame, but it doesn't fulfill the insulation criteria. Okay, Of course, the American, again, has a different way of measuring. Where there's load bearing, you have restraint rating, unrestrained rating. It's a little bit different from the approach of the European and the British standard. Okay, now we go to the main portion of today's presentation. We have already good background. We must remember REI, remember reaction to fire and resistance to fire. Okay, so the Singapore Fire Code. Today I need to qualify myself. I'm only very familiar with passive fire protection. I'm not so good. I understand a bit of the active, but I'm not very good. So I'm making a little bit of reference to the NFPA. And our fire code, you can actually get it free from this website. There's also a performance-based fire code that you also can get from the website. Okay, in my presentation, a lot of illustrations, and it may not represent a real building, but it's just to illustrate what I'm trying to portray. All right. The fire code has altogether 11 chapters, but today I will only concentrate on chapter 3, chapter 7, and chapter 9. The rest, we don't have enough time to dwell. Okay. So starting from understand to approach the fire protection of a building, we need to understand this term in the fire code, Singapore Fire Code, called purpose group. We have small residential, other residential like condo, institutional, office, shops, place of public resort, and factory and storage. Okay, so something like that. Uh-oh. I am stuck. How come? Good. Okay,
yeah.
So very good. Now I go to I was advised to also share a bit of the NFPA way of approaching this. NFPA call it classification of occupancy and hazard. I took this from NFPA 1, and it's very, very similar to the way Singapore Fire Code classified. The Singapore Fire Code and the British way of building document B and even the Malaysia Fire Code follow this purpose group 1 to 8. NFPA uses different words, but it's about the same thing. So here is an interesting comparison. You have nursing home, train station, data center, aircraft hangar, student hostel, hotel, blah, 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 different kind of users, yeah? And I here share with you what the Singapore Fire Code would call this, classify this purpose group. So what is interesting is hotel is place of public resort. A data center is a factory. The hangar is a factory. Yeah, the airport is a place of public resort. That's how they describe it. Now, let's look at how NFPA classify this. Really bit different. You know, data center is called storage occupancy. The train station is called assembly occupancy. And then the hotel is called residential occupancy. So it's a little bit different. But why is purpose group so important? Because it actually tells you the hazard level of the space in use. It tells you how many people you must calculate that can use this space, how many exit and what is the size of the exit you must provide for these people, and what is the limit of the compartment size in terms of volume and floor area, and what period of fire resistance. Remember the word resistance to fire. The structural flame, the compartment, how many hours you need to build this space, okay? Now, the fire code in Singapore also explicitly tell you when resistance to fire is, what does it mean? Okay, because in a building, there are many ways of, many parts of the building can be exposed to fire and may not be exposed to fire. For instance, a column that is exposed to 4 sites, or a column that is exposed to 3 sites, or a column that is exposed to 2 sites will have a different way of measuring the risk, right? A load-bearing floor, you should expect the fire from underside. An external wall that is very far away from the boundary, then they say, okay, you need to make sure the fire from inside of the building doesn't spread to the outside. But if the external wall is very close to the boundary line, you need to prove that whether the fire comes from the inside or from the outside, this wall must be able to resist the fire. Okay, so next slide. And if your wall is a compartment wall, it doesn't matter whether the fire comes from unit A, it must not go to unit B, your neighbor. Your neighbor's fire cannot come to your house. So these are compartment wall. You must prove that whether the fire comes from either side, that wall must be able to resist the fire. Okay, very complicated table that tells you the actual requirement of the fire code. But just a very simple, I let you see, it will tell you structural frame, floor, external wall, and whatever parts of the building, what criteria must you fulfill? So you notice the word stability or load bearing capacity, integrity, and insulation. So basically, they are referring to REI. Okay, it tells you this REI, if it's a structural frame, is it required or not? Is it not required? It also tells you from which side of the fire it must resist, from outside, from inside, from underside, from every side. Okay, so this is how the fire code tells you how to prove this element or structure, how to resist fire. I draw some reference from NFPA 5000. It also has very similar way of telling you the kind of construction and the resistance to fire period. Okay, now we go to very important element called compartmentation. Compartmentation divide.
Miss Lin,
Yes.
shall we have a break here so that we can recap the previous session? Since,
Okay, good. Yeah.
Yeah,
sure.
there are many people who just came in.
All right.
Okay, thank you. สวัสดีค่ะท่านที่เพิ่งเข้ามาในห้องประชุมนะคะก็คุณลินนะคะท่านที่เพิ่งเข้ามาใหม่นะคะก็คุณลินก็ได้นำเสนอ2 section แรกไปแล้วนะคะเป็นในส่วนของเรื่องdefinition ของ REI แล้วก็ในส่วนของ occupancy definition ของ Singapore Fire Code compare กับ NFPA นะคะก็จริงๆแล้วคุณถ้าใครไม่ได้เข้ามาตั้งแต่ต้นนะคะคุณลินแกมีประสบการณ์ในเรื่องของ passive fire protection system มามากกว่า30 ปีแล้วนะคะก็วันนี้เขาก็จะมานำเสนอประสบการณ์แล้วก็ความรู้ในเรื่องของการป้องกันอัคคีภัยเชิงรับนะคะหรือ passive fire protection system เนี่ยให้พวกเราทุกคนฟังนะคะซึ่งตัวที่ทางคุณลินได้พูดไปเบื้องต้นแล้วเดี๋ยวแพรจะขอ recap สั้นๆนะคะก็จะเป็นเรื่องของ REI นะคะ R เนี่ยก็คือload bearing นะคะอันนี้คือหมายความว่าโครงสร้างของเราไม่พังไม่งอนะคะไม่เสียหายนะคะไม่สูญเสียความปลอดภัยนะคะที่ถูกออกแบบไว้นะคะตัว E นะคะย่อมาจาก integrity นะคะก็คือจะไม่มีการที่ว่าควันจะผ่านผนังหรือว่าชิ้นส่วนโครงสร้างในส่วนที่เราได้มีข้อกำหนดตรงนี้นะคะผ่านไปได้นะคะทั้งควันแล้วก็ทั้งเปลวไฟนะคะในส่วนของตัว I นะคะคือ insulation คำนี้เนี่ยก็คือหมายถึงว่าอุณหภูมิที่อยู่อีกฝั่งหนึ่งของผนังนะคะฝั่งตรงข้ามของที่ไม่โดนไฟนะคะคือห้ามมีอุณหภูมิสูงเกิน180 องศานะคะไม่ว่าในกรณีใดๆทั้งสิ้นแต่ตัวค่า average เนี่ยต้องไม่เกิน140 องศานะคะโอเคก็คือเขาพยายามจะปูพื้นฐานให้เราฟังกันก่อนนะคะว่า REI เนี่ยคืออะไรเพราะว่าในตัว Singapore Fire Code เองเนี่ยก็มีการกำหนด requirement ต่างๆ refer มาที่ตัว REI ตรงนี้นะคะอันนี้ก็คือ section แรกจบไปนะคะส่วนตัวที่2เนี่ยจะเป็นเรื่องของ occupancy นะคะซึ่งเขาในสไลด์เนี่ยเราก็กลับไปดูหลังจากนี้กันได้นะคะว่าในแต่ละoccupancy type หรือว่าการใช้งานฟังก์ชันต่างๆของตึกเนี่ยอย่างเช่นสถานีรถไฟairport หรือว่าจะเป็นโรงแรมเนี่ยนะคะถูก classify ว่าให้เป็นoccupancy แบบไหนซึ่งสิ่งต่างๆเหล่านี้เนี่ยก็จะมาเป็นตัวตัดสินชี้นะคะว่าrequirement ตัว RTI ของแต่ละ occupancy เนี่ยเราจะมาใช้ยังไงกันนะคะเดี๋ยวจะขอเชิญคุณลินพูดต่อในส่วนของ file compartment นะคะ Okay, Lin, you can please continue on the compartmentation.
Okay, good.
Thank you.
Okay, compartmentation. What is it? I think we are quite familiar already. Compartmentation is basically the word, remember, divide. You divide a big space into a smaller space. Say a factory, you want to divide it into different spaces so that one side, when it's fire, it wouldn't spread to the whole building. Compartmentation also means dividing the usage. One side is office, one side is a storeroom. You want to prevent, because of the different risks, you want to compartment these two spaces. Compartmentation is also for separation between two units. One is different owner. So your party wall is also a compartment. Okay, so how does, I mentioned just now, the purpose group is very important because it determines the number of occupants, the number of exit. It also determines the control of the floor area and the volume, as well as the period of fire resistance that is required. Okay, so here I take a simple example. Let's say purpose group A. It's called a shop. Okay, in NFPA it's called merchandise occupancy or something like that. All right, so imagine you have a shop and you want to, you want to have no limit on the height, no limit on the floor area, and no limit on the cubicle extent. Okay, if it's above ground, this compartment must be 2 hours, and if it is in the basement, it should be 4 hours. Is it? I'm not seeing it. Yeah, so the fire code actually tells you the usage, the size that you want to control, and because you want it very generous, no limit, then any space, the room that and surround compartment this space must be 2 hour fire rated. If it is in the basement, it will be 4 hours. Yeah, again, I draw some reference from NFPA 5000. It's also very similar, different users, and it also tells you the building height and whether there's limit or no limit. Okay, I'm not very familiar with NFPA. I'm just drawing some similarities. Yeah? So there's a limit compartment to limit the spread of fire and restrict or resist the movement of smoke. Again, NFPA 101 also has different uses: assembly, merchantilable, detention, which is a prison probably, ambulatory is a healthcare, and it tells you if it is the between this space and this space, let's say between a mall and a hotel, then you need a 2 hour fire separation, a compartment. That's how the NFPA works. Yeah. The fire code also limits if your building is up to only maximum 24 meters high, you are allowed to have a space, consider one compartment, right? But not more than 3 stories. But if your building is more than 24 meters high, every floor must be a compartment floor. Okay, but for basement, every floor is a compartment floor. Yeah, so you also compartment because of different risks, different usage. So like for instance, this is dividing the admin office from the production area. So you have a fire protection subdivision. Or within this warehouse, the volume is too high or the area is too big, then you also need to divide the space to comply with the limits of the compartmentation. So this is compartmentation, yeah. And it's very similar to NFPA, because this kind of room, storeroom, AHU, kitchen, generator room, oil tank room, all these are considered higher risk, and there is specification as to how many hours compartmentation is needed if your building is non-sprinkler or your building is sprinkler protected. So there's different requirement. You know, I'm showing this because our fire code has many clauses that are linked together. So it's just very good reference for us to have this protection from hazard subdivision. Okay, now I go into external wall. Why is external wall important? Because your building, you must make sure that the fire from your building must not spread to your neighbor. And your neighbor's fire must not spread to your building. So the external wall is quite important. NFPA also gives you specific requirement on the fire resistance of different kind, for the external wall for different kind of usage, from assembly to merchant shops to industrial. And it tells you how far you must site the building away from the boundary wall. Okay, so now I show you a Singapore fire code. If your building is assembly purpose group 7 and is more than 1 meter away from the boundary, you need to prove fire from outside. If your building is more than 1 meter but other kinds of usage, you must prove fire cannot spread from inside out. And finally, if your building is less than 1 meter from the boundary, you must prove that which side the fire comes, you must not allow the fire to spread to the other side. Now, I'll give you an example how they decide, because your external wall cannot be opaque fire resistant wall. You must have windows, you must have doors, you must have glass. So how many percentage of your external wall is allowed to have unprotected opening? They call that unprotected opening means an ordinary glass or just an opening that has no fire resistance. There's a control in the fire code. Example is a building that is 9 meter high, 18 meter wide, and it is 8 meters away from the boundary. I give you an example. This is a building, it's 9 meter high, 18 meter wide, and the boundary, the fire code also tell you what does the boundary mean, because sometimes you don't have a boundary wall. For this building, there's no boundary wall. You measure the boundary from the middle of the road and say this is 8 meters from the middle of the road. In this case, you are allowed to have 90% of this wall comprising of unprotected opening. That means it can be ordinary glass or just an opening that it has no fire resistance. That's how they allow you to design the amount of external space that is unprotected. I give you an example. Here is for different kind of purpose group. This part all the warehouse and the storage space. And you have this building that is 15 meter high, 80 meter long, very long, and it's only 8 meters away from the boundary line. Not 9 meters away from the boundary line. In this case, you only allowed to have 20% unprotected opening. So that's how they decide the amount of openings you can allow on the external wall. The rest of the wall must fulfill, just now I mentioned, whether fire from inside or fire from outside. You must test the wall to prove that you can resist fire from inside or outside. Okay? Any question?
May I ask you a question?
Yes.
This is a requirement about the safety distance, right?
Yes.
In between a building or structure.
Yes.
Any exception for like if the sprinkler has a sprinkler, we can reduce the distance, safety distance for Singapore court?
No.
No.
No. But you cannot reduce the distance, but you can reduce the wall. The wall is a part of a storage, right? And based on this purpose group, the wall needs to be 2 hours. But because you have a sprinkler, you can reduce the 2 hours to 1 hour.
But the opening, the unprotected opening cannot. Okay.
Cannot.
Thank you.
They will reduce the resistance to fire, period, not the opening size.
Okay, thank you.
Okay, so similarly, I take again some reference from NFPA, very similar, but they decide on whether your building is light risk, moderate risk, or severe risk, and they have some kind of calculation as to a multiplier as to how many building to building separation you require. So I haven't studied this table well, but it seems to approach the same problem as the Singapore Fire Code. And now we talk about again external wall. It's getting very popular. Solar panel, right? Solar panel now even are used on the external vertical wall of a building. I don't know whether this is popular in Thailand or not, but it's getting very popular in Singapore because we are pushing for net zero, I think 2030, if I recall correctly. So when you have, so there's a regulation introduced into the fire code, and this is actually in chapter 10, not covered in those chapters I mentioned. If you have a solar panel on the wall, the first panel must be 5 meters from the ground level. And that wall that mount the solar panel must be at least 1 hour fire rated. Okay, but let's say you can't help it. You must start the solar panel from 3 meters. Then you need to provide a 1 hour fire rated horizontal kind of like a fin. We call that projection, to prevent the fire from the solar panel from burning downwards. So these are some of the regulation. Then we have also getting very popular to have solar panel on metal roof. Like now we are doing 3M has a very big factory in Singapore, and on their metal roof, they want to put solar panel. So the concern is the energy store may catch fire, and by doing so, it may burn downwards. Okay, so if your building is sprinkler protected, you need to have a protection between the solar panel and the roof underneath. Just a non-combustible material is good enough. But if the building is not sprinkler protected, you need to put a 1 hour fire resistant separation. Okay, so you have a building, you have the solar panel, and then you need this fire resistant separation between the solar panel and the bottom of the roof. If this roof is for car park, linkway, both sides are open, you don't need to have this protection. Another concern they have is many buildings have this podium and tower thing. They are concerned that the fire from the podium, it may burn upwards and go to the tower. So there's a requirement. If that is so, at least 5 meters of the roof of the podium must be fire resistant. Or if you don't do that, 9 meters of the external wall of this tower cannot have opening, must be fire resistant. So this is vertical fire spread. Compartment walls also join to other parts of the building. For instance, a compartment wall can join to an external wall. A compartment floor can also be joined to an external wall. Similarly, compartment wall or separating wall join with the roof. So the requirement is all this junction must be bonded and fire stop. That's the word they use, bonded and fire stop. So I have some examples of this where you have a compartment floor and an external wall. You must make sure the gap between the external wall and the concrete floor is fire rated, is fire stopped. Yeah, fire stop. So we have some systems that do this function. Okay, Per, would you like to summarize?
Yeah, thank you. ค่ะก็เซกชันที่ผ่านไปนะคะก็คุณลินเขาพูดถึงเรื่องไฟคอมพาร์ตเมนต์นะคะหรือว่าการสร้างกำแพงกันไฟนะคะเพื่อไม่ให้ไฟเนี่ยลุกลามต่อเนื่องไปในพื้นที่อื่นๆนะคะก็ในส่วนของตัวไฟคอมพาร์ตเมนต์เนี่ยมันก็มีจุดประสงค์หลายอย่างแต่ว่า2อย่างหลักๆเลยก็คือการไม่ให้พื้นที่ที่มีความเสี่ยงอย่างหนึ่งนะคะไฟที่เกิดในพื้นที่ที่มีความเสี่ยงอย่างหนึ่งเนี่ยลามไปในอีกพื้นที่หนึ่งที่มีความเสี่ยงที่แตกต่างกันนะคะอันนี้คืออันแรกก็คืออย่างเช่นที่เขายกตัวอย่างก็คือ เป็นมอลล์กับโรงแรมอย่างเงี้ยค่ะสมมติว่าเรามีโรงแรมที่อยู่ข้างๆอยู่ในตึกเดียวกับมอลล์ mixed use อะไรอย่างเงี้ยนะคะก็คือต้องมีไฟล์ compartment ตรงนี้นะคะแล้วก็อีกส่วนหนึ่งที่ไฟล์ compartment จะเข้ามามีบทบาทเนี่ยก็คือเป็นเรื่องของ hazard protection นะคะคือพื้นที่ห้องที่อาจจะมีความเสี่ยงสูงนะคะอย่างเช่นจะเป็นห้องเครื่องห้องที่มีกระบวนการห้อง engineering ห้องอะไรต่างๆอย่างเงี้ยนะคะที่อาจจะมีความเสี่ยงมากกว่าห้องอื่นห้อง storage อะไรพวกเนี้ยนะคะซึ่งในส่วนของไฟล์ compartment เนี่ยค่ะ requirement มันก็จะแตกต่างกันไปเชื่อมโยงมากับบทที่แล้วที่เขากล่าวถึงในเรื่องของ occupancy หรือว่า purpose group ที่แตกต่างกันนะคะตัวไฟล์ compartment requirement เนี่ยก็จะแตกต่างตามกันไปด้วยนะคะในส่วนของในกฎของสิงคโปร์เองเนี่ยถ้าสมมติว่าเป็นตึกที่สูงกว่า24เมตรเนี่ยเขาจะกำหนดให้แล้วก็เบสเมนต์นะคะชั้นเบสเมนต์ทั้งหมดเนี่ยจะกำหนดให้ทุกๆชั้นต้องเป็นไฟล์คอมพาร์ตเมนต์ของตนเองนะคะคือไฟไม่สามารถลามข้ามชั้นได้ซึ่งมันก็ไม่ได้หมายถึงแค่พื้นผนังหรือว่าเพดานนะคะก็คือจะต้องมีตัวไฟสต็อปซึ่งพื้นที่ระหว่างที่พื้นไปชนกับ curtain wall ต่างๆพวกนี้ค่ะทางคุณลิงก็คือเน้นย้ำว่าเราจะต้องซีลต้องบอนพวกรูพวกแกะต่างๆพวกนี้ค่ะให้เรียบร้อยด้วยนะคะเพื่อให้เกิดประสิทธิภาพสูงสุดนะคะของการไม่ลามไฟในส่วนของพวกwarehouse นะคะก็จะมีลิมิตrequirement จากกฎโค้ดสิงคโปร์เองเนี่ยก็จะกำหนดเป็นไฟล์ compartment area เอาไว้นะคะว่าพื้นที่ห้ามเกินเท่านี้นะคะต้องทำเป็นไฟล์ compartment นะคะก็คือเราก็อาจจะเห็นว่า warehouse บางที่ก็อาจจะไม่ได้ใหญ่โตนะคะก็จะมีกำแพงกั้นเป็นส่วนๆนะคะเพื่อที่ว่าไฟล์ compartment area เนี่ยจะได้ไม่เกินนะคะในส่วนของเมื่อกี้เขาพูดถึงเรื่องโซลาร์พาเนลนิดนึงนะคะเพราะว่าช่วงนี้ก็คือจะเห็นกันบ่อยนะคะในโปรเจกต์ต่างๆนะคะถ้าอยู่ในวงการการออกแบบเนาะก็เขาบอกว่าในกฎของสิงคโปร์เองเนี่ยก็มีออกมาใหม่ที่อัปเดตนะคะก็คือว่าตัวโซลาร์พาเนลที่ติดเป็นแบบvertical หรือแนวตั้งเนี่ยนะคะต้องอยู่ห่างจากชั้นหรือพื้นต่อไปติดกันนะคะเกิน5เมตรนะคะถ้าสมมติว่าไม่เกิน5เมตรเนี่ยจะถือว่ามีความเสี่ยงในการที่ไฟจะลามจากโซลาร์พาเนลเนี่ยลงไปที่อื่นได้เขาก็จะต้องมีการติดตัวฟินหรือว่าตัวไฟเลเต็ดเป็นเพื่อกั้นไม่ให้ไฟจากโซลาร์พาเนลเนี่ยลามไปในจุดอื่นๆต่อไปได้นะคะตัวผนังที่ยึดโซลาร์พาเนลเองก็ต้องเป็นไฟคอมพาร์ตเมนต์1ชั่วโมงด้วยต้องกันไฟ1ชั่วโมงด้วยนะคะก็ประมาณนี้นะคะใครมีคำถามอะไรเดี๋ยวขออนุญาตตอบทีเดียวในตอนหลังเลยนะคะสามารถทิ้งคำถามไว้ในแชทได้นะคะแล้วก็ตัว presentation เห็นมีถามมา 2-3 คนนะคะก็เดี๋ยวหลังจากนี้ค่ะเดี๋ยวเราจะส่งเป็น presentation ให้นะคะหลังจากจบเผื่อว่าคุณลินมีอะไรจะแก้ไขจะได้เป็นตัวอัปเดตไปเลยขอบคุณค่ะโอเคลิน
Okay, thank you. I shall continue. I do not know whether the NFPA uses the same terminology, but this terminology called protected structure is also very critical to fire protection. A protected structure is the wall, the floor, or any part of this building that encloses a shaft. This shaft goes from the ground, maybe from the basement, all the way throughout the whole building. It can be a shaft that contains a staircase. It can be a shaft that contains electrical services running throughout, or a shaft that contains a lift, a shaft that contains air ducts or other MEP services. So this shaft goes throughout the whole building, and there are specific fire resistance requirement for the protected shaft. So I just share a little bit on this today. Now, here is just an example, a shaft containing kitchen and mechanical ventilation. It passes through various floors, and it can serve, the ventilation can serve the staircase, the smoke stop lobby, areas of refuge, emergency generator, or whatever. So what is the requirement in the fire code? Firstly, it must be compartmented from one another. So an MEP, the lift shaft must not be sharing with a MEP shaft, okay? And secondly, the whole shaft must be enclosed in a masonry construction or a fire-rated drywall, so something like that, right? I jump very quickly because for the shortage of time, we will go straight your shaft we have covered already. But again, you know, when you have your shaft wall, your compartment wall, your very, very good fire-rated floor, but you cannot have a building with no services. So many services will puncture through your floor, your wall. And these services sometimes are like combustible pipes. For instance, I may point to you some pipes that go through your wall, the pipe burns and it softens and a hole can be left behind. So various forms of fire stopping is used to prevent the fire from spreading through this opening, whether the opening is created by cables or the opening is created by combustible pipe. So we have systems that seal up the opening or seal fire collar that go around the plastic pipe that crushes the pipe during a fire. So when we have more time, you can approach L'Aquatec to find out more about this kind of fire stopping. So the regulation in Singapore is electrical riser, every floor must be fire stopped. If it is a telephone riser, every 15 meters must be fire stopped. And, you know, Singapore being very exacting, they even specify that sometimes you have a trunking in the riser and the trunking has a cover. And inside the trunking, there is a true opening. So the specification, the regulation even tells you that inside the trunking, the gap must also be fire stopped. So it's that detailed, right? Again, our NFPA 5000 also specify fire stopping. And I mentioned earlier just now, the ASTM way of measuring fire stopping performance instead of REI, it is using the word FE. FE represents the EI of the European standard. Okay. Now we go into ACMV or HV or kitchen exhaust ducts. These are ducts we cannot escape. You will have ducts going through your entire building. And these ducts, sometimes where it passes the compartment wall, you can have a fire damper. But not all ducts you can stop the fire from spreading one place to another by a fire damper. For instance, a smoke extract duct, a ventilation duct, a kitchen extract duct. You cannot have a fire damper where the wall passes through the compartment wall, when the duct passes through the compartment wall. So what do you do? Because if you don't do anything, the fire can burn through the duct and spread to the other side. Some examples here, a situation where you have the duct going through two compartment wall and there's no opening. This duct is being burned on the outside. If it's not fire resistant, it will be twisted and it will crack and the fire will spread from one side to the other side. So this duct is being burned on the outside only. But for duct, it's very complicated because sometimes you have a duct with an outlet and within a compartment. And it can burn, it can suck fire into the duct while it's being attacked by fire on the outside of the duct. So this is a duct that has been attacked by fire inside and outside. So how do you ensure that the fire doesn't break through to the other side where the man is walking, where it is supposed to be safe? So I introduce you to this terminology called duct A and duct B. Okay. The European standard has some guideline, or the British standard has some guideline how to test, because what we are concerned is on the outside of the fire, you are safe. The fire doesn't spread through the duct to the safe side. Yeah. So they require, the standard require us to test two tests. One, a duct A, where you prove that the fire is burned on the outside of the duct. Now, in doing this test, the duct is connected to the fan. So it's a real life, you know, you don't have a duct with no air movement, yeah? So it's connected to a fan and it's probably introducing negative pressure inside the duct. And you have the duct B, where it is being attacked by fire because of the opening there is internal and external fire attacking this duct B. So this is a way of testing and proving whether your duct is fire resistant or not. And the same requirement of REI also applies here. R means stability, the duct cannot collapse. E is integrity, no gaps and crack, and I is insulation, doesn't exceed the maximum temperature of 180 degrees or 140 degrees average. So for that, it's also REI. Example in the fire code where a fire resistant duct is required. If it is an aircon duct, of course, you can put a fire damper, because during a fire, the damper will, your aircon doesn't need to work, so it will block off the fire from spreading from one room to another. But the duct serving an area passing through the smoke-free lobby or passing through the fire lift lobby must be fire rated. Your engine pump room, your generator room, your fire command center, the duct running outside the duct, this room must be fire rated. Okay. I give a very practical example here of kitchen exhaust duct. It's very common where kitchen exhaust duct exhaust the kitchen fumes outside the building. And if it's outside the building, and you have windows also outside the building, so what we are concerned is that if the kitchen is on fire, it draws the fire out of this exhaust duct, and it's too close to a window, the fire will spread through the window back into the building. All right. So the fire code actually gives some guideline. You must not be too close to the opening. Minimum must be 3 meters. If it's at a corner, it must be minimum 1.5 meters. But it's not always possible. Yeah. Sometimes the kitchen, the commercial kitchen of the restaurant has to run the duct in a certain way. So if it doesn't meet the requirement, then you need to protect this duct with a fire resistant enclosure. I show you a real example. Here is a kitchen duct from a restaurant downstairs. It is less than 3 meters from the window. In this case, the entire external kitchen exhaust duct has to be fire rated. So in case there's a fire in the kitchen, this duct that draws the heat and fire out will not burn to the neighbor. Okay, so this is fire resistant duct. Another example of a commercial kitchen happened that the duct must pass through maybe a restaurant area to go to the outside. So this portion where it is outside the kitchen should be built of a fire resistant duct. Okay, so these are some examples. There are many ways to make the fire resistant duct. What are the requirements for smoke ventilation duct? Minimum 1 hour. And the fire code in Singapore also explicitly tell you it must prove it can take internal and external fire. And if it passes through a wall of 2 hours, the fire suppression must be 2 hours. Okay? So, yeah. So some examples, ways of making a fire-resistant duct. You can make the duct out of fire-resistant material. You can paint over the duct, or you can box over the duct. Yeah, so some examples here. Okay, I think I have reached my time limit. Oh, one more important, smoke reservoir. A smoke reservoir is like an upside-down fish tank. Instead of collecting water, it collects smoke. So the requirement in the fire code is that this clear area for the smoke must be 2.5 meters. So basically, you want to collect the smoke within a reservoir so that it doesn't spread throughout the entire space, because if the smoke starts to cool down, the smoke will go down and affect the escape for the people, right? So there's some requirement on the size of the smoke reservoir. If it's a natural ventilation, it's 2,000 square meters. When if it is a mechanical smoke ventilation, it's 2,600 square meters. And fire from circulation for the atrium is a smaller smoke reservoir. So I saw our colleagues just now showing, smoke curtain. Smoke curtain are operable ones that comes down during a fire. You can also have static smoke curtain. smoke screen, we call that fulfills the EN 12101 requirement. Okay. Important, I thought it's good to share too. Our buildings are getting taller and taller. Our residential buildings are now more than 4 stories high. And I think in Bangkok as well, there are many very tall buildings. The fire code requires, they classify a building that is taller than 40 stories as super high rise. And when your building is super high rise, every 20th floor, you must have a refuge floor. And within this refuge floor, you must have an evacuee holding area that has minimum 50% of the refuge floor. And this evacuating holding area must have that natural ventilation with openings of 25% of the area. It must have direct approach to an external corridor. It must have access to a smoke-free lobby. It must have access to a fireman lift. So these are some requirements in the fire code for super high-rise building. Okay. Per, would you like to summarize?
Hi, Lynn. I think you're pretty clear, but I'll just do a really quick recap on the fire stopping. Yeah. Okay. ค่ะก็ที่เมื่อกี้ที่คุณลินเพิ่งพูดไป chapter สุดท้ายนะคะก็ค่อนข้างชัดเจนอยู่แล้วนะคะคือเป็นเรื่องของ fire stop นะคะก็ทางตัวโค้ดของสิงคโปร์เองเนี่ยหรือกฎหมายไทยเองก็เช่นกันนะคะก็ค่อนข้างชัดเจนในเรื่องของการลามไฟแนวดิ่งนะคะเช่นพวกห้องไฟฟ้าประจำชั้นต่างๆช่องชาร์ฟต่างๆพวกนี้นะคะคือเราจะต้องซีลไม่ให้ไฟลามข้ามชั้นนะคะไม่ว่าด้วยวิธีใดวิธีหนึ่งนะคะอย่างกฎสิงคโปร์เองเนี่ยเขาค่อนข้างไปละเอียดยิบเลยนะคะคือว่าแม้กระทั่งแก็บของในตัวรางสายไฟหรือว่าช่องระหว่างรางสายไฟกับตัวชาร์ฟเองอะไรแบบนี้นะคะก็คือต้องอุดให้มิดชิดทั้งหมดนะคะในส่วนของสายไฟเองทุกๆ15 เมตรนะคะก็จะต้องมีการเบรกนะคะเพื่อให้เป็นไฟคอมพาร์ตเมนต์ด้วยนะคะไม่ให้ไฟมันลามต่อไปนะคะในส่วนของที่เขาพูดมาประเด็นสำคัญเลยก็คือเป็นเรื่องของแอร์ดักต่างๆนะคะที่เราไม่สามารถปิดไฟแดมเปอร์ได้นะคะซึ่งแอร์ดักพวกนี้ก็จะอยู่เต็มไปหมดเลยนะคะในตึกที่เราเห็นกันนะคะก็คือแอร์ดักตรงนี้เนี่ยทางโค้ดสิงคโปร์เนี่ยก็คือค่อนข้างชัดเจนว่าจะต้องเป็นมีไฟเรเตนนะคะตัวการเทสไฟเทสก็เหมือนกับอย่างอื่นrequirementเหมือนกับตัวอื่นเลยนะคะก็คือใช้ criteria REI นะคะก็คือไม่พังไม่งอไม่มีรูรั่วให้ควันหรือว่าเปลวไฟออกมาได้อุณหภูมิต้องไม่เกิน180 องศา average 140นะคะก็เหมือนกับตัวที่เราคุยกันตอนแรกเลยนะคะ criteriaซึ่งนอกจากนั้นแล้วเนี่ยดักที่เป็นพวก kitchen duct ที่เราเลื้อยออกไปนอกกรอบอาคารนะคะทางสิงคโปร์เองก็มีกฎนะคะว่าห้ามตัวดักเนี่ยห้ามอยู่ใกล้ช่องเปิดเช่นหน้าต่างเป็นต้นนะคะเพื่อไม่ให้ควันหรือไฟเนี่ยลามกลับเข้ามาในอาคารนะคะซึ่งตรงนี้เนี่ยถ้าเราไม่สามารถทำได้จริงๆเนี่ยเขาก็อนุโลมให้สามารถสร้างเป็น enclosure เป็น fire rated enclosure ครอบตัว kitchen exhaust ตัวเนี้ยไปได้อีกนะคะสุดท้ายนะคะเขาก็พูดถึงเรื่อง smoke reservoir นะคะว่าโอเคในวิธีการดีไซน์ในเรื่องของ smoke control system นะคะการกักควันเวลาเรามี atrium หรือว่ามีถุงต่างๆเนี่ยก็ทางกฎหมายบ้านเขาก็จะมี requirement ในตรงนี้ด้วยว่า clear height ที่คนสามารถวิ่งไปมาได้เนี่ยจะต้องอยู่ที่ 2.5 เมตรนะคะประมาณนี้แล้วก็สุดท้ายเขาพูดถึงเรื่องตึกสูงนะคะที่จะต้องมี refuge area refuge floor นะคะทุกๆ40 ชั้นมั้งคะเนี่ยที่เขาพูดอยู่ตอนนี้นะคะ20 ชั้นค่ะ40 ชั้นเนี่ยต้องมี1 refuge นะคะซึ่งก็ต้องเป็น fire compartment 2 ชั่วโมงนะคะให้คนสามารถพับออกมาจากบันไดได้นะคะมาอาจจะต้องมีปฐมพยาบาลหรือมาหลบภัยนะคะในจุดตรงนี้โอเค Lynn yeah translated your last section yeah
yes very quickly I bring you back to Bangkok I share with you a Bangkok situation you see the fire code also tells you your concrete structure how much concrete cover you must have in order to fulfill the fire resistance. But if you have an old building, the concrete cover may not be enough. So the European standard has a way of testing and collecting the data to tell you using different methods, using a board material, a paint material, or spray material, right, to make up for the shortage of the concrete cover. So we approached this problem in one of the projects in Bangkok, which is the UNISCAP building, where it is an old building, it's 25 stories tall, and the concrete cover was not enough. So they are using this EN test, they decided to upgrade the concrete cover using a board material. So these are some projects I thought it is of interest to show you. And this was actually done in collaboration with La Aquatech. Yeah, I think that brings me to the end of my presentation. Thank you very much. And you've been very good audience.
Thank you very much, Lin, for your really good and comprehensive presentation. We have got a few questions that the audience left in the chat group.
Yes.
Okay. Some of them has already been deleted, but I'll communicate the ones that are still on here. Most of the people find your presentation very interesting. They would like to have this presentation in a hard copy.
Yes.
Yeah, drop loads of emails. Okay. ในไทยเราตอนนี้มีกฎจากคุณธนาคารนะคะไม่ทราบยังอยู่ไหมนะคะ